All right, hey all. Thanks for having me. Looks like I'm really excited to be here. Looks like y'all have had a great event. So, thanks for having me. I'm gonna hop right in here. My name is Alex Debrie, and this talk is about using DynamoDB in serverless applications. Before we start, I want to tee it up a little bit and talk about what are serverless applications. How does this sort of all fit together? So, most people, oops, hold on, my slides aren't working. There we go. Most people, when they think about serverless, I think they want to start with AWS Lambda, and Lambda isn't the only thing in serverless, and it isn't all of serverless, but it is a very important part of serverless, and it really kicked off this whole serverless revolution where you have this fully managed on-demand pay-per-use compute that you just sort of upload your code and it runs when you want it to run. And you upload your code to Lambda, you get that going, but the important part is they're running the code when you want it to run. So then you need to get some event sources in there. So that's where maybe something like API Gateway comes in, right? You add API Gateway and you say, hey, when this HTTP endpoint is invoked, I want you to run my Lambda code. And now it's great, right? You have an endpoint, you have some code, it's running, it's all great. But even that is not quite enough. Usually you need to pull in some other services. Your Lambda needs to interact with something with that HTTP endpoint. So it might be something like Amazon S3, right? When a request comes in, you process it in Lambda and you save the result to S3. Or it might be something like SQS, right? Like a queuing service where you enqueue a message in SQS and you go process that later on in some sort of background job. But very often it's a database, right? You have to add some sort of database to your application where you're going to be writing data, reading, updating, deleting data, all things like that. So that's a lot of what this talk is going to be about, using databases in your serverless application, and specifically DynamoDB, because you have these different options of databases in your serverless application. You can use something like RDS if you want a relational database. You can use DocumentDB if you want something more like MongoDB, but DynamoDB has been really popular in service applications. We're going to talk about why in this talk here. So this talk is about pro tips for using DynamoDB in serverless applications. A couple different things we're going to cover here. Number one, we're going to start off with why DynamoDB and serverless, because I think Dynamo has been the database of choice for serverless applications, over the last 4 or 5 years. And I want to talk about why that is, why it fits so well in the serverless paradigm, and why so many people are choosing it. Once we've gotten past that sort of introductory stuff, we're going to talk about the basics of DynamoDB data modeling. We're going to talk about some vocabulary, because there's differences between a relational database that you might be used to and then DynamoDB. There's also some differences in concepts between DynamoDB and relational, and the data modeling principles are really different between these two. So we're going to talk about that here, talk about some underlying background on why that's the case. And then finally, one of my favorite parts is we're going to talk about some one-to-many relationships. And this is where it gets practical, and you can really start to see those differences with DynamoDB and relational databases. I think that really brings it home. So that's one of my favorite parts. Who am I? I'm Alex Debrie. I wrote the DynamoDB book, and I also created DynamoDBguide.com, which is just a free resource out there, just sort of an introductory resource to Dynamo. I'm an AWS data hero, worked with DynamoDB a lot and a lot of other databases at AWS. And then finally, I'm a serverless engineer at Steady. I mentioned the DynamoDB book. If you want to go check that out, it's a really comprehensive guide to data modeling with DynamoDB. It's got 450 pages, a bunch of extras if you need them. It talks about relationships, sorting, filtering, uniqueness, all sorts of stuff. And it has 5 walkthrough examples that I think really bring it home. So if you want to go check that out, dynamodbbook.com if you want to learn more about what you see in this talk today. So with that, let's get started. Let's talk about why DynamoDB is so popular in the world of serverless. And there are a couple different reasons here. The first couple reasons I think DynamoDB has picked up, and the ones I'm going to talk through, is just how much it seems sort of like other AWS services within your applications, and it feels very similar to something like that. So the first reason is just around the interaction mechanics, how you actually use DynamoDB in your code. It feels like using any other AWS service. So let's look at a quick example of this here. Here's some Python code, and imagine I'm using SQS. I talked about that earlier. That's Amazon's simple queue service. I might be using that in my application, and here's what it would look like to use it. And it's basically going to be 3 steps. Number one, you're going to import the library. So here I'm importing Boto 3. This is the AWS SDK for Python. So I import that into my application. I'm going to create a client. So I'm creating an SQS client here that's going to interact with that SQS service. And then I'm going to call a method on that client, client.sendMessage. That'll enqueue a message in my SQS queue there. Likewise, if you want to look at something like S3, this is what working with S3 would like. And again, you have the exact same pattern: import library, create client, call method. Very similar there. So then let's look at DynamoDB and see what that looks like. And you'll see it's very similar. Again, same sort of pattern. You're going to import your library, you're going to create your client, you're going to call your method. And if you're used to working with other AWS services like you often are with AWS Lambda, working with DynamoDB feels very similar in that way, just in terms of the interaction mechanics and what that looks like. So I think that's one reason that DynamoDB has been pretty popular with serverless. The next one is around the permissions model and how you think about permissions with DynamoDB. And so I've got an example here of some IAM role statements. This is in my serverless YAML if you're using something like the serverless framework to handle your serverless applications. But basically, I have some IAM role statements. This is saying what my Lambda function can do. What permissions does my Lambda function have? What services can it interact with? And you can see at the top there, I'm giving it permission to do SQS send message. So that API call I was making with my SQS queue, I'm giving it that send message permission. Here's what it looks like here. I've got an effect, I've got an action, and then the resource that it applies to a certain SQS queue. That's what it looks like to set up my SQS permissions. So if you're using other AWS services in your AWS Lambda, you're going to be doing something like this. Likewise, if you look down below, that's my DynamoDB permissions. Same sort of pattern we're doing here. You have that effect, you have that action, you have that resource. It's all built together here in the same way for your other AWS resources. So I think that's really useful. Another thing that's really great about the way the permissions model works with DynamoDB and with Lambda is your Lambda is going to get associated with an IAM role that has different permissions. You can reach out to SQS, you can reach out to Dynamo. When that Lambda function is created, they're going to inject some temporary credentials into that environment for you. And then those are automatically discovered by that AWS SDK. So earlier on, when I was importing Boto 3, creating that client and calling out to AWS, it would just automatically pick up those credentials in my environment. And then you as a user don't need to think about credential management. You don't need to think about secret rotate or credential rotation, secret management, any of that stuff. It's all handled for you. And just to contrast that with, like a relational database, if you were working with a relational database, it wouldn't be using IAM like this. You'd have to have some different set of credentials to connect to that relational database. You'd have to think about how to manage that, how to rotate those, but also setting up those permissions within your relational database rather than using something like IAM for this. So I think that's another reason why people are really liking DynamoDB in this serverless world. Another reason here is just the provisioning model, how you actually set up your DynamoDB database. Again, I've got some CloudFormation here that's setting this up. I just want to compare and contrast SQS and DynamoDB. So there at the top, I'm setting up my SQS queue. I'm saying what type of resource it is and the properties. And then same thing with that DynamoDB table. I can create that DynamoDB table directly in CloudFormation, which is great. And I'd say infrastructure as code, it's a pattern that's predated the serverless world, but it's really taken off and become a must-have in the serverless world because you're managing so many resources and your infrastructure is a part of your application in a way that it wasn't before, where you really need some sort of infrastructure as code tool to handle that. So, you see tools out there like CloudFormation and Terraform that are pretty popular. I'd say CloudFormation probably more popular in the serverless world just because of the tooling that's built up around that. But the big thing about that, you get consistent repeatable deployments, which is really great. And people love that. Again, just contrasting that with like a relational database, you can provision a relational database using CloudFormation, using infrastructure as code tools, but often there's some sort of post-provisioning step outside of CloudFormation that you need to do to get it ready for your application. So you need to do things like create your table, create your indexes, create your users and give them permissions, create some credentials and store those somewhere. And that's something that's difficult to do in the infrastructure as code tools as they already are. Whereas, with DynamoDB, you can create your table, you can create your indexes, you can create the users and the access on that table all within CloudFormation. So you don't have like sort of this two-step process. That works out really well. Next reason that people are really loving DynamoDB with serverless applications is the billing model. I think they've made a couple improvements on their traditional database billing model, as compared to a relational database. And this has been on two axes. First of all, you're paying for reads and writes directly rather than sort of these abstract resources, right? So if you think of a traditional database, you have to provision some instance and you have to think, how much CPU, RAM, IOPS do I need? And that's actually like a pretty tough thing to do, right? You can maybe do some capacity planning and think I'm going to have this many users next month. They're doing this many queries, but then you have to say, how do those queries actually translate into CPU and RAM? And that's just a black box, sort of a guess in terms of how that happens. With DynamoDB, in contrast, you're paying for what are called read capacity units and write capacity units. So when you do a read against DynamoDB, you just look at how big that read was. Was it a 2 kilobyte read? Was it a 10 kilobyte read? You can actually calculate the RCUs it's going to take. And you can have a pretty good guess of how much you need to provision to actually satisfy your needs. So they're billing you for that directly, how much you're actually reading and writing rather than CPU or memory or anything like that. So I think that's a big improvement. But even if that much capacity planning is too much for you, they also have pay-per-use. So they have this traditional provision capacity. You say, I want this much RCUs and WCUs sort of pre-provisioned for me. But you can also just do pay-per-use, where you say, you know what, I'm not going to provision anything ahead of time. I'm just going to do reads and writes against my table, and you send me a bill later. And on a per read or per write basis, this can be more expensive, but that assumes you have pretty high utilization on that provision capacity. A lot of people don't, so pay-per-use actually ends up being cheaper, especially when you factor in all the time and costs it takes to figure out how much capacity you should provision, things like that. So I think both these huge improvement on traditional database billing models. Last thing about DynamoDB and how it works with serverless is around the scaling characteristics. And this is really important. And this comes on two different axes here. First of all, there's the connection model. So traditional relational databases, they're assuming a persistent connection from sort of a small fixed number of compute instances, right? So you spin up an EC2 instance, it sort of initializes, makes a connection pool, and then that's like a pretty long-lived stateful connection between that's reused a lot. But with Lambda, right, you have all these little compute instances sort of firing up all over the place on demand as your compute comes in. And each one of those needs to make a connection to your database. And a lot of relational databases have connection limits on how many connections they can have at once. And you can easily hit that limit with your Lambda functions, and then you actually can't access your database if you do hit that limit. So that's a problem for a lot of people. You don't have that same problem in DynamoDB with the way their connections work, which are just over basic HTTP. The second issue is around performance during scaling, and how does DynamoDB handle scaling? And DynamoDB was really built for massive scale, and I think this is sort of an underrated underappreciated point about DynamoDB and how it scales. So I just want to talk a little bit with a little bit of a chart about how DynamoDB scales. And here we have a chart. On the bottom, you could think about your data size, right? And these are just rough numbers, but maybe you have a gigabyte of data when you're testing or just new, and then you have 10 gigs as you're starting to get more users, and eventually you're growing, you get 100 gig and a terabyte. And then on the y-axis, you think about performance, right? And it starts at blazing fast, and eventually it slows down to just fast, and then sluggish, and then to painful. Now, if you're working with a traditional database like MySQL, you might have a performance curve that's something like this, right? When you're in your test environment, when you're running locally, or when you don't have that many users, you're blazing fast, right? All the data can be in memory, indexes can be in memory, all that stuff, and it's really quick. At some point, you're going to start to get more users, and it's going to slow down to just regular fast. And then you're going to get more and more users, and it's going to slow down to sluggish. And that's when you need to go investigate, right? And you need to say, hey, what's going on with my database instance? Why is it getting slower? Do I need a new index? Do I need to do some denormalization, different things like that? And then at some point, it might get so bad that you need to actually re-architect your system and say, hey, we're at a level of scale that we didn't plan for here to handle this. So one thing with relational databases or traditional databases is it can just have this sort of long-term drag where you're always having to tweak stuff as your data grows. Let's contrast that with DynamoDB's performance. And DynamoDB's is more like this, right? It's a pretty flat line. So if you look there on the left, it's not going to be quite as blazing fast as a MySQL if you only have a gigabyte of data. But the great thing about Dynamo is, as you scale from 1 gig to 10 gig to 100 gig to a terabyte, you're going to get the exact same performance. You're going to get the exact same performance in your test environment as you do in production. And that's a real benefit, I think. A lot of people really like that, where you don't have to go back and keep re-architecting your data to handle new load. So that's the last reason, people really love Dynamo. I think those 5 reasons are really important. So, if you're sort of sold on Dynamo, let's go in and let's talk about the basics of data modeling with Dynamo, because again, it's very different than modeling with a relational database. I want to start off with some vocabulary about DynamoDB. So 4 key terms you need to know as you're working with Dynamo, and those terms are going to be table, item, primary key, and attributes. We're going to walk through this by way of an example. So I have a session store here. So imagine you have an application that has some authentication. Users can log in with their username and password. You'll create a session token, store it in the database, and hand it back to them. And then they'll send that session token back on subsequent requests to identify themselves. So here is some example data here. I've got some Marvel characters, 4 different Marvel characters all together to help walk us through this. If you look at all this data together, this is going to be called a table, right? So this is going to be similar to a table in a relational database, or maybe a collection in MongoDB, if that's what you're more familiar with, but it's all your data together. If you look at an individual record, that's going to be called an item. So one record is going to be called an item, comparable to a row in a relational database or a document in something like MongoDB. Now, when you create your table, you're going to have to specify a primary key on your table, and every item that you put into that table must contain that primary key. That primary key is going to uniquely identify each item in that table. So you won't have 2 items with the same primary key. They would just overwrite each other if you did that. And primary key is going to be very important for data modeling. We'll talk a little bit more about that later on in this presentation. In addition to the primary key, you also have other attributes here. So I have things like username, created at, expires at. You don't need to specify these attributes in advance on your DynamoDB table. So attributes would be comparable to columns in a relational database. Other than that, you don't need to specify them, right? So in a relational database, you need to say, hey, I have a username column, I have created at, I have expires at, here's the type. DynamoDB doesn't have that. For that reason, DynamoDB gets called a schemaless database, and that's true in some sense, right? There's not a schema that's enforced in the database. It doesn't mean that you shouldn't have a schema. You need to have a schema if you want to have any sanity in your application with your data. So what it means is sort of the responsibility for validating that schema is happening at your application layer rather than at the data layer, right? Dynamo is not going to yell at you for having the wrong attributes in here as long as you have the proper primary key there. So with the attributes, you can have strings and numbers as we might have here, or you can also have complex types. You can have lists or maps or sets. So lots of flexibility with the attributes there. I want to talk a little bit more about the primary key, because again, the primary key is very important in your data modeling with DynamoDB. There are 2 types of primary key when you're working with DynamoDB. So there's the simple primary key, which has just a partition key. And then there's what's called a composite primary key, which is made up of 2 parts, a partition key and a sort key. So if we go back to our previous example here, that session store, that's a simple primary key, right? It's the primary key has 1 element. It's that session ID. This is when you're using DynamoDB as basically as a key value store. You can get and receive, or you can write and retrieve 1 item at a time, only operate on a single item at a time, mostly not multiple items. If you want to work with a composite primary key, here's what that looks like. So here's a table we have. This shows actors and actresses in the different movies they've had a role in. So it's just showing movie roles for actors and actresses. And you can see our primary key has 2 parts here. It has the partition key of actor, and that's going to be the actor name. And here we have Tom Hanks, we have Tim Allen, we have Natalie Portman. But then it's also got the sort key of movie, and you can see Castaway, Toy Story, and Black Swan. A couple of things I want to point out here. Note that it's the combination of those 2 elements that must uniquely identify an item. So in this case, we have 2 items that have Tom Hanks as the actor, but because they're different movies, we have Castaway and we have Toy Story, that's okay. The combination of those 2 is unique, and that's going to be unique for our primary key. Same thing with the movie, right? We have 2 people that are in Toy Story. We have Tom Hanks and Tim Allen, but because those actors are different, that's okay. Again, it's uniquely identifying that item. I would say if you're doing more complex applications, you're usually going to be using a composite primary key because this allows you to operate on multiple items at a single time. You can retrieve multiple items that have the same partition key and do more advanced operations there. I'm going to go a little bit into how Dynamo data modeling and how you think about Dynamo is different than a relational database. But I think up front, let's think about what I call DynamoDB's guiding principle. And this is not in the AWS docs anywhere. This isn't sort of mentioned by the DynamoDB team or anything like this. But I think this underlies every single decision they make. And that is, we do not want to allow operations that won't scale. So what they're doing is they're sort of limiting what you can do intentionally so that you're going to get that scaling chart that we saw before, right? Where it's consistent performance over time. And that's what we see here, right? Dynamo will not allow you to do operations that won't scale. So you get that consistent performance chart. So given that, let's talk about the basics of data modeling with DynamoDB. And we're going to talk about two things that are pretty important and then the implications of those different things. So first of all, the importance of primary keys. So primary keys are very important with your DynamoDB data modeling. They uniquely identify your item, which is important before, but they also drive most of your query patterns. So if we go back and look at our composite primary key example, this is that movie roles table. We see that primary key on the left there. When you're sort of querying and reading your data, you're going to be operating on those primary keys. So it's very easy to go to DynamoDB and say, hey, give me all the movies with Tim Allen in it, or give me the movies for Tom Hanks that are between this and that in the alphabet, right? We can do that very easily. On the other hand, you can't efficiently query with those other attributes. The way our data is currently set up, you couldn't go to this table and say, hey, give me all the drama movies between 1998 and 2000. That would not work. That wouldn't be an efficient one because that's in that attributes thing. So you really need to think about your primary key because that's going to help, or that's going to be what drives your access patterns. So you need to design it in a way that makes sense for your access patterns. The second thing about DynamoDB is there are no joins. And this is the biggest problem bugaboo or whatever you want to say for people that come from a relational world, right? They're saying, where's my joins? And I want to talk a little bit about why there are no joins, just conceptually. So, so far we've been talking about DynamoDB as it's this, sort of large monolithic, maybe there's this giant computer somewhere that holds all your data. But really that's not what's happening. That's not what's happening behind the scenes. DynamoDB is going to be split into what's called partitions. And you don't need to know about this necessarily to work with DynamoDB, but I think it helps your sort of mental model to understand how DynamoDB works. So behind the scenes, there are two partitions, and they're going to split up your data across these partitions and basically hold about 10 gigs of data on each partition. So as your data grows, they'll add more partitions to help split this up. And this is really important because let's just walk through what's happening when a request comes into Dynamo. So let's say someone wants to write a new item into that movie roles table. They're doing that put item request, and they're saying, hey, it's the actor of Tom Hanks, and the movie they're putting in is big. So what that DynamoDB front end, that's called the request router, what it's going to be doing, it's immediately going to hash that actor function value and then determine which partition that item belongs to. So in this case, it hashes Tom Hanks and says, hey, this item belongs to partition 1. And the beauty of this is it allows you to grow pretty easily. So you can add a third partition and it's going to work really well. You can add 6 more partitions and it's going to work really well. And the awesome part is that first step is a constant time operation. So even as your data grows, as you get from 1 gig to 100 gig to 10 terabytes, if you're at 10 terabytes and you have all these different partitions, that very first step is going to be a constant time operation where they hash that and look it up in a hash map to see which partition it belongs to. So immediately, even if you have this 10 terabyte table, you're narrowing it down to the right 10 gigs of data that you're going to be sort of querying within. And that helps keep your data consistent, right? It helps you get down to what you actually need to do. Anyway, so this is how Dynamo is happening behind the scenes. The reason there are no joins is because it adds a lot of complexity in sort of how you distribute and partition that data, right? Because now you need to partition multiple different tables to make it join, so you're not doing sort of cross-partition network requests. So rather than doing that, they're just saying, hey, you can't do joins at all. We're going to have one single table that's sort of partitioned on this partition key. Yeah, excuse me. All right, so Basics of data modeling. Importance of primary keys, very important for your access patterns. No joins because of how that partitioning works. A couple implications of that downstream. Number one, you should know your access patterns in advance. And this just sort of changes how you model your data as compared to a relational database and patterns there. So with a relational database, you often, make your entity relationship diagram, your ERD first to see your different objects and see how they relate to each other. And then you often just sort of ship that ERD to your database and you say, okay, every box in my ERD becomes a table. And then I set up some relations between them using, foreign keys, things like that. And then once I've done all that, done that modeling, then I say, hey, what queries do I need to write to assemble my data in the right way to handle my access patterns? With Dynamo, that's flipped. You're going to start with your ERD again, just to know how your application fits together, how the boxes and lines work. But then you want to say, hey, how am I going to access this data, right? And once you know how you're going to access your data, then you design your table specifically to handle those access patterns, and you build your primary key based on your access patterns to handle that. So in our movie roles table, we could get movies by actors, but maybe we don't have an access pattern to get movies by genre or different things like that. So that's why we put it in attributes rather than in our primary key. Some people get tied up on this because they think knowing your access patterns in advance means you can't change later on. That's not true. You can absolutely add new access patterns as you need to. I've got some examples in the book if you need to do that. It's pretty straightforward, but the big part is you're going to be designing your table for these access patterns specifically rather than designing your table in an abstract way and then thinking about how to access it later on. The second implication of this, and this one really throws people for a loop, but you often put all your items into a single table and you use these generic attributes for your primary key. So in contrast with a relational database, where you might have a customers table and you have an orders table, and those are separate and you join those together. We don't have joins here, so we're going to put all our data into a single table and query it that way. This throws people for a loop, so I want to walk through an example here just to see a little bit of what that looks like and how you handle something like that. So for an example, let's imagine we're building a SaaS application. Organizations can sign up for our SaaS applications, and within an organization, users can take actions within that application. So we're building an application. We have two entities that we're working with here, organization and users. We're going to put those into a single table and sort of see what that looks like. So let's get started with some organization items. Here's my table. I put two organization items in here. I have Berkshire Hathaway. That's from my hometown of Omaha. We also have Facebook in here. A couple things I want to call out here. First of all, look at that primary key and look at the names we have for our primary key values. We're using that composite primary key, but we're using very generic names for our primary key values. So our partition key is just named PK for partition key. Our sort key is just named SK for sort key. And we're using that instead of something like organization name or username or something like that, because we have different sorts of items in this table, and it wouldn't make sense for some of those. Some of those don't have those attributes. So it wouldn't make sense to have an organization name, if we're having organizations and users here and users don't have an organization name. So that's why we have these very generic names for our primary key values or primary key attribute names. If you look at the values themselves as well, you can look at that, and there's kind of this weird template that you're using for your application values. And for this one, we have a prefix of ORG for organization, hash, and then we have the organization name. And that's doing a couple different things for us. Number one, it's identifying the type of entity we're working with here. Since we have different types of entities in here, we can use these sort of primary key patterns to help identify what type of entity we're using there. It also helps to prevent overlap between different types of items. If you had an organization and a user that happen to have the same name, they would collide and overwrite each other. But here, by having that prefix, we can identify, hey, one's an organization, one's a person. We won't have that overlap. So we've got our organizations in this table. Let's add a couple of users in here. We've done that here. We've still got our organizations in here, but now outlined in red, I've added these three users. So I've got Charlie Munger and Warren Buffett for Berkshire Hathaway. I've also got Sheryl Sandberg for Facebook. A couple things to note here. Just note that, again, they're using those generic primary key values, again, PK and SK. They have a slightly different pattern in terms of what that's going to be. So the partition key, the PK value, is the same because users are within that organization. But then the sort key value is different. It's a user hash and then username that's sort of identifying those items. Another thing to note there, if you look at the attributes, notice that the attributes are different between these types of entities. So organization has attributes like organization name, subscription level that makes sense for an organization, whereas that user has attributes like username and role that makes sense for that user. And again, that's where that schemaless nature of DynamoDB comes in again. Since you're putting different types of items into this table, you can have different attributes for them. You validate that in your application rather than at the database layer. Last implication I want to talk about with DynamoDB is you really need to learn and know your strategies. And I call these strategies, and it's basically just different ways to model data in DynamoDB. And we're going to go into one-to-many relationships next. And if you're working with a relational database, there's basically one way to model a relational, or sorry, one way to model a one-to-many relationship. It's going to have that foreign key that sort of links them together, and then you do a join across that. But as we're going to see, there are multiple ways to handle one-to-many relationships in DynamoDB, and you sort of need to pick the right one for your situation. Same thing with many-to-many relationship, 4 or 5 different ways to do that. There's different ways to handle sorting and filtering, different requirements you have that way. So you really need to learn these strategies and figure out how to apply them to your situation. So with that in mind, I want to go into one-to-many relationships, show some strategies just to get a sense of how you sort of handle some of this stuff, with this sort of single table DynamoDB design. So let's talk about one-to-many relationships. First of all, I just want to talk about what one-to-many relationships are, and that's going to be any situation where there's some sort of parent entity that has related sub entities. So perhaps in your application, you're storing different offices and multiple employees work at a particular office. So that office is that parent entity, and then there are employees that are related to it because they work at that office. If you're building an e-commerce store, it could be customers and orders, right? Your customer comes and signs up, and a customer can have multiple orders, but that order belongs to a specific customer. So there's a one-to-many relationship there. Finally, in that example we saw already with that SaaS application, you can have organization and users. An organization signs up, allows multiple users within its organization to perform actions. So this is a one-to-many relationship. When you're working with a one-to-many relationship, the key problem you're sort of thinking about how to model is how you get information about that parent item when you're fetching related items, right? So if I'm fetching a user within an organization, I might also want some information about that organization, the organization name, their subscription level, different things like that. Or if I'm fetching information about a customer's order, right? How am I going to get information about that customer, their shipping address, their payment method, different things like that. So that's the big key problem that you're usually working with a one-to-many relationship. When you're working in a relational database using SQL, the answer of how to do that is to normalize your data and use joins, right? So you sort of normalize your data so you don't duplicate anything. You have your customers table, you have your orders table. There's a link between those, so that order table will have a reference out to the customer, to that primary key of that customer, and you can join those together. But again, in DynamoDB, we don't have joins, so we're not going to be doing that. So there are multiple different strategies in DynamoDB of how to handle one-to-many relationships. And, it might involve denormalization. We're going to see 2 examples of when you denormalize your data. It might involve a single table design and this sort of query operation, which we're going to see as well. So with that, we're going to walk through 3 strategies here. I actually have 5 in the book, but I think these 3 are sort of the most important ones. And given the background we have, I think this will work here. So the first strategy I want to show is what's called denormalization and complex attribute. And the example I want to set up here, let's build off that SaaS example that we already have. Let's imagine that when an organization signs up for our SaaS application, they can set up multiple payment methods, right? So they need to pay for a SaaS application. Maybe they can set up multiple payment methods because if the first one fails, it can fall back to another one. So there's a one-to-many relationship between the organization and the payment methods because they can have multiple payment methods on file. When you're sort of thinking about that, you think about how do I access these payment methods, right? And you're really not going to be accessing those payment methods directly. You're not going to be saying, hey, I have a credit card number. Who does this belong to? You're more going to be saying at the end of the month, okay, it's time to go bill Berkshire, or Facebook, pull up Facebook's account and then look at their payment methods and run through those. So given that, here's the strategy we're going to do. We're just going to add an attribute directly onto that organization item itself. So I've outlined it in red. This is an attribute called payment method. And this is going to be a complex attribute. It's going to be a map that stores a lot of different values in there, like just like a dictionary or a map in your programming language of choice, right? So we've got multiple values in there. I have like the default payment method and the backup. We're denormalizing data here. You wouldn't do this if you're sort of normalizing your data, because one of the principles of database normalization in a relational database is each column value should be atomic, right? So you shouldn't be able to break it down any further, but this has lots of different values in there. So in a relational database, you'd split these out into a different table and do some joins. We're going to do this one here. So that's the first pattern here, denormalization, a complex attribute. This is good when the following things are true. Number one, you don't have an access pattern on that related item directly. So again, like I was saying, you're not going to be querying saying, hey, I have this bank account, who does it belong to? Or I have this credit card, who does it belong to? I don't have an access pattern on that directly. Rather, I have these access patterns on the parent that I need some of that related stuff. So I can query by the parent, and that related stuff just comes along for the ride, which is great. It's also good when you have a limited number of related items. Because DynamoDB has a 400 kilobyte limit for an individual item. So you can't just keep adding more and more larger and larger attributes to your item. You're eventually going to hit that limit. So you wouldn't want to do this with something like customers and orders, right? Because you want people to come back to your store and make more and more orders, and you don't want to reject an order because the item size is too big. You don't want to say, hey, sorry, you can't make that order because we didn't design our database properly. That'd be a mess. In this situation, you're not going to let people sign up with 150 different payment methods, so it's okay. You can say, hey, you only get 5 or whatever it is, and you have more than enough room. So that's the first strategy you might use. Second strategy is another denormalization strategy, and this is denormalization plus a duplication. So let's look at another example here. This is maybe you have an online bookstore, right? And you're selling books, and you have all the different books in your table. And you can see I have 3 books here. I have a couple by Stephen King. I have It, I have The Shining, and then I have one by J.K. Rowling. I got Harry Potter on there. I mentioned that the big problem you're going to have with a one-to-many relationship, that key problem is, how do I fetch information about the parent item when I'm fetching a related item? And here what we have is, on our books, we're storing information about that author birth date. So you can see for both of these Stephen King books, I have the author birth date in there, and I'm duplicating data here, which is, again, this is something you would not do in a relational database. You don't want to duplicate data in a relational database. If you find yourself duplicating data, you split that out into another table and sort of have pointers to that, those references there, and that can help with some data integrity issues. So when do you use this denormalization and duplication strategy? I'd say this is good when that duplicated data is immutable, right? So in this example, Stephen King's birth date is not going to change, I imagine. So you can have it there. It's going to be immutable, and that's going to help with your data consistency stuff. If you're not going to be updating this data, you don't have to worry about it. So that duplicated data is immutable, or I would say it's mostly immutable. It doesn't change often, or if it does change, it's not replicated much, right? And so it's sort of a balance there. Like, if this data very rarely changes, it's okay to sort of duplicate it in a lot of different places. Or conversely, if it's only replicated across 2 or 3 items and it's easy to find those items and update them when that data does change, maybe you do want to duplicate that data. So the big thing here is around data integrity, right? There are reasons within normalization where you don't want to duplicate data, and it's because that update stuff, are you sure you can find all the places where that data exists and update it in all those locations? So you need to think about that here when you're using that duplication strategy. Last strategy I want to talk about is composite primary key and query. This is a fun one. So let's go back and let's look at our table. This is our SaaS example. Again, we have organizations, we have users. If you look here, we have multiple items that have the same partition key. So we have multiple items with the same partition key, and we can query directly by a partition key in DynamoDB. So there's an operation called query that allows you to fetch all items with the same partition key. So we could do that here. In this case, we can use org #Berkshire, and that would get us these 3 items back. And again, this is a very efficient operation because of this chart that we talked about earlier. Remember, at the very beginning, the first thing that happens whenever you're writing an item to Dynamo is you're going to hash that partition key and figure out which partition it goes to. That's a constant time operation. The great thing now is that all items with the same partition key are going to be on the same partition, so you can easily retrieve all those if you want to. That's going to be a constant time operation as that grows. Really great. So what we can do here is we can fetch all items with the same partition key. Now, all items with the same partition key are called an item collection, and an item collection is an important part of data modeling in DynamoDB. What you can do is you can assemble item collections that have different types of entities in them to allow you to fetch just what you need. So if you look in this example, I have 3 items, but they're different types, right? I have that parent organization item, but I also have those related user items down below. And what I've done is basically pre-joined my data, right? If I have an access pattern where I say, give me all the users for a particular organization, but I also need to know some information about that organization itself, I've already pre-joined that data here to where I can query that very efficiently. It's going to be a fairly constant time operation. It's going to grow a little bit as your data grows, but pretty constant time, and it's going to be nice and efficient compared to a SQL join. So the important part about that composite primary key in the query is that you pre-join your data in that item collection. Again, an item collection, it refers to all items that have the same partition key there. So those are the 3 sort of strategies I want to talk about for one-to-many relationships. A couple main takeaways I want to talk about with DynamoDB generally is you have to learn the strategies. You have to sort of have these basic building blocks, right? Like know these different one-to-many relationships. When do I want to denormalize with complex attributes? When do I want to denormalize with duplication? When do I want to use this sort of item collection, this composite primary key plus query? Same thing with many relationships. And then you really need to understand your application needs. And that's when you're modeling out your thing, you need to think about your needs. And as we were walking through those one-to-many relationships, we saw, hey, this is good in this situation. This is good in that situation. You need to understand those needs in your application to help choose the strategy that works for your sort of situation. The last one, I think this is the hardest for a lot of people, is just get comfortable with denormalization. We've sort of gotten used to all this normalization with relational databases, and there are a lot of good things about normalization, but understand when you can sort of flex that a little bit and relax that constraint and get comfortable with denormalization. Make sure you're not painting yourself into a corner or doing some bad patterns, but you also realize that the hard and fast rules around denormalization aren't necessarily required. So that's all I have. Quick summary here. First of all, we covered why DynamoDB and Serverless. I think it's the most popular database within serverless applications, and we saw why, right? It fits really well just in terms of very similar to other services, a great billing model, and then also scales really well. Given that, if you bought into DynamoDB and Serverless, we talked about some basics of modeling. We talked about some of that vocabulary, as well as some of those basic principles around DynamoDB data modeling. And then to bring it home, we looked at some one-to-many relationships, saw how that's different in DynamoDB as compared to a relational database, and hopefully that was helpful there. So, hey, thanks for attending. I'm going to take questions now if there are any, but yeah, really appreciate y'all.